Equation number 3 of this section F. So here it was mentioned in class, but I have to be honest, we did not linger too much on that. The base, which is 5 minus x, not only has to be greater than 0, but also cannot be equal to 1. And I will have another inequality, which would be this one here. X squared minus 2x plus 65 has to be greater than 0. So here I will have negative x greater than negative 5, therefore x is less than positive 5. Here, negative x has to be different than 1 minus 5, which is negative 4, and therefore x cannot be positive 4. Let's now solve that quadratic inequality. I'm going to cross over this addition of 65, and here I'm going to complete the square with those two terms. I will have x minus 1 square. So I could subtract 1 here or add the missing square over there. It's going to be the same thing. Anyway, here I am getting that x minus 1 square has to be greater than negative 64. Now, here you have to stop. Think about it. If you cross over the square, you will end up having a square root here, but you cannot have the square root of a negative number in the set of real numbers. But it doesn't matter, because in that case, a square is always positive. So necessarily, this will always be true. You can eventually justify that by saying that x minus 1 square is necessarily greater than or equal to 0. Therefore, this is always true. So the domain for this part is all real numbers. So I've got, if I report all of that information on a number line, I've got 4, 5. So x has to be less than 5. It cannot be equal to 4. And the third one, it's all real numbers. So the domain of validity is this one, with 4 being excluded. So if I conclude that using interval notation, x belongs to the interval negative infinity 4 excluded union 4, 5. So this is my domain of validity. Now let me rewrite the whole equation. And here it's going to be rather simple. I'm going to cross over that logarithm. So the argument of the logarithm will remain here, and this logarithm is going to become a base. Then I am going to distribute the right side. I will have 25 minus 10x plus x squared. Both x squared nicely cancel each other. And I will have negative 2x plus 10x, which is 8x, and 25 minus 65 is negative 40. Therefore, x equals negative 40 divided by 8, which is negative 5. And here, because it is included in the domain of validity, I do not need to go further.